As you may know, to properly disassemble, inspect, and repair a Koomey regulator, it would take even the most experienced subsea hand an hour or two. Well, even with the magic of video, we couldn't show you the procedure in much less time than that, certainly not in 15 or 20 minutes. So we're going to rely on you. In these Koomey repair programs, we intend to point out highlights, critical aspects of the repair procedures. These are going to be points that a manual can't stress properly by printed words. Everything else is up to you. These valves are deceptively simple. Despite the many small parts they have, you can easily repair one of these regulators as long as you have the proper materials on hand when you repair. Those materials are your rig manuals and the manufacturer's valve drawing. In this program, the first in the Koomey repair series, the 1-inch MKR and HKR valves are the subject. The two are similar, and the internal workings of both valves are nearly identical. So we've grouped them together in this one program, and we'll point out differences as we go along. In addition, both valves can regulate at two different supply pressures, 5,000 and 3,000 psi. Some of the internal parts vary slightly in size from the 3,000 to the 5,000 psi valve, and the 5,000 psi valve has a noticeably larger body size. To give you an example of both sizes, the MKR in this program is a 5,000 and the HKR is a 3,000. This won't affect the disassembly and reassembly methods described in this program. But if you have to replace parts, you'll need part numbers. So make sure you know what supply pressure feeds the valves you're working on. Then pick up the proper valve drawing. It'll have the correct part numbers you need. When you pull the valve from the stack and bring it to your subsea shop, remember safety. Before you pull any valve, make sure system pressure is vented. Even though all pressure gauges read 0, loosen hose fittings slowly. Often there will still be a little pressure left in the lines. Make sure your work area is clean and keep plenty of clean rags on hand. These intricate valve parts must be kept dirt-free. Before you do anything else, unload the spring. Turn the protective cap counterclockwise and take it off. Loosen the lock nut. And rotate the adjusting screw counterclockwise until it turns freely. Only then will the spring be unloaded. If you pull the spring housing before it's unloaded, you'll launch the spring parts or the housing. Then, before disassembly, check the flanges and valve body for reference marks, like so. In some cases, like here, you won't be able to find them because of seawater corrosion. You'll have to mark them yourself. You must reinstall the flanges exactly as you took them off. This is for two reasons. First, the internal porting requires it. Second, you want to make sure the fittings face the right way so the valve will fit back in the stack. Now the disassembly process begins. As you take the valve apart, handle the pieces gently. Don't force anything. Don't yank on any of the valve internal parts or the flanges. If you have to, gently tap on the flanges with a hammer. Then work them loose by rotating the flange back and forth. You've got several flanges to work on, and it doesn't really matter what order they come off. The cap screws in the 5000 come in two different sizes. The smaller ones attach the bottom and outlet flanges. Remove the pilot valve body carefully. Remember the poppet is inside and attaches to the seal container. If you don't pull the pilot valve body off carefully, you could damage the poppet. If you wish to release the poppet while the seal container is still in the valve, remove this pipe plug here. You'll have access to the screw that holds the poppet to the seal container. When you remove this snap ring in the pilot body, use only snap ring pliers to remove the ring. Be careful, don't just yank it out of there. If it snaps off the pliers, it may jump at your hands or face. Several precautions when you pull the pilot valve housing. First, tap this spring pin back into the body. Make sure it's all the way back out of the way. If the spring pin's not completely back, it'll gouge the housing when you tap it out the top. It is best to tap the housing out the top instead of the bottom. The large O-ring around the body may force you to use a brass rod to get it out. And since the O-ring is at the top of the housing, you'd be fighting it all the way if you tried to push the housing out the bottom. Be careful as the housing is about to come out. Don't smack it all the way out with a hammer. The last hit will knock it onto the floor. As it's about to come out, just grab it with your hand and carefully work it until it comes out. This is the large O-ring that may have forced you to struggle a bit with the housing. Remove it and all the other O-rings in the valve. You're going to replace each one. Use a small screwdriver like this to remove them. When you pull them, be careful not to scratch or score any ring grooves. Make sure you have your new seal kit on hand. You'll want to match the old O-rings to the new ones. You have to replace each O-ring with an identical new one. At this point, you see that all the flanges are removed. You're looking at the seal container through the inlet side. Notice that the indentations face this way toward the inlet. After you remove the seal container, you'll have to reach in from the bottom with the brass rod to tap out the plunger guide. If you ever have difficulty pulling a valve part by hand, use a brass or wooden rod and nothing else to get it out. After using the rod, make certain any brass or wood chips have been cleaned away before you reassemble the valve. When you push out the seal rings, don't use any metal object, not even a brass rod, to get them out. Use your fingers to do the job. Make sure they're coated with hydraulic oil or other light lubricant. This will keep corrosive skin acids away from polished metal surfaces. Just in case you reuse the seal rings, keep them in some kind of order so that you'll replace them exactly as you took them out. Quite simply, each valve builds its own wear pattern. In other words, the seals and plates get used to each other. Provided with new rubber, the valve works just fine. But if you change the plates or seal rings around, you mess up the wear pattern, and the valve may never work right again unless you replace everything. When you clean the valve parts, be as thorough as possible. Clean every seal surface, ring groove, flange face, bore, etc. Use a solvent or diesel. Even soap and water will do. There's also a venting system through the pilot valve body. Make sure those small passages are unclogged. If you have to, you can use emery cloth or steel wool to remove mud or dirt buildup. But make sure the emery cloth or steel wool is soaked in solvent, and use either gently. And never use emery cloth or steel wool on the seal rings or plates. If they're so dirty that you can't simply wipe the dirt off with your rag and solvent, then replace them. Inspection and reassembly. We're going to be a little more detailed in this section of the program, so many of your inspection and reassembly procedures are critical. In general, carefully inspect all the ring grooves throughout the valve, on the plates, the flanges, the seal rings, the plunger, any ring groove. Look for nicks or burrs that could cut the new seals. If you find this kind of damage, see if you can smooth it with emery cloth. If not, replace the part. All internal metal parts come in the repair kit. In particular, let's look at the seal rings. Inspect the outside edges of the seal rings. They seal against the seal plate and around the inlet port. If they're damaged, any nicks, uneven surfaces, or scoring, replace them. Fluid is leaking over them. And if you have to replace the seal rings, replace the flow and seal plates also. If the rings are damaged, chances are the plates are too, even if you can't detect it with the naked eye. The seal container. The outside of the seal container doesn't have any seal surfaces. It should be in good shape. Check to see that it's smooth. If you find any pits or scoring, check the inside of the valve body. There may be some damage that coincides with the damage on the seal container. Then check the seal ring bores. They should be clean and smooth. Any nicks, burrs, or irregular wear patterns may damage the O-rings around the seal rings and affect the integrity of the seal. And check the plunger to see that it's smooth and straight. If it's not straight, replace the plunger. And inspect the guide bore in the plunger guide. If you noticed any scoring on the plunger or torn plunger seals, there may be damage inside the bore. It too should be clean, smooth, and straight.
That's fine.
The poppet. Check the Teflon tip. Look for any wear. If it's worn, replace the poppet. You'll find it in the repair kit. By the way, valves regulating 5,000 psi supply pressure require a different sized poppet than the 3,000 psi regulators. Notice the slight size difference here. So be sure you have the proper repair kit containing the right poppet on hand. This holds true for all your internal parts. The repair kit intended for a 3,000 psi valve will not work in a 5,000 psi valve. Check the pilot valve seat where the poppet tip makes contact. Look for any sort of damage or irregular wear patterns. Replace the seats if you find these conditions. Let's move on to the pilot valve housing. Inspect inside the center of the housing. This is where the poppet slides back and forth. If you found any scores on the poppet or seals, it's probably the result of a burr inside here. The only seal surface on the outside of the housing is the ring groove. The rest of the surface isn't very critical, but look at this scratch. It seems that someone didn't get the spring pin out of the way before they replaced the housing last time. So as it was going by, the spring pin scratched it all the way down the side. It probably got the O-ring too. It was never able to seal properly. Whenever you remove or replace the pilot valve housing, be sure the spring pin is completely out of the way. The plates and flanges. Wipe off the seal plate surface and check these wear marks on both the seal plate and port plate. Even though the marks are very visible, the surface of the plate must still be smooth. If it's not, replace the plate and the seal rings. One note here. The plates are different sizes from the 3,000 psi to 5,000 psi valves, so they're not interchangeable. On the mating surface of the inlet port, be sure these edges around the port are smooth, since the O-rings seat here. When you're satisfied that the inspection process is complete, put all your new seals in place, and several general reminders here. Lubricate each seal before you install it. No matter what type of hydraulic fluid you're using, use a light lubricant to protect the parts and ease assembly. And remember these cautions. If you're reassembling with natural rubber seals, don't use a petroleum-based grease. Such a lubricant will eat at natural rubber, and recent studies have shown that silicone lubricants may have an adverse effect on valve parts and seals in saltwater applications. Do use lightweight hydraulic oil, vegetable oil, or your hydraulic concentrate. The most important caution, don't over-lubricate. A simple light coat will do for each seal. And if you use a grease as a lubricant, understand that over-lubrication and grease will trap dirt and debris that may get into your BOP fluid. Soon it'll collect and severely damage the valve. This is especially critical in working seals. Seals that move in relation to metal parts. If they collect debris, they'll rub it across metal like sandpaper. This lubrication is simply designed to aid you in the assembly of the valve. If the seals aren't lubricated, they'll be difficult to slide against metal. That's all. So don't pack the valve full of lubricant. It's not good for the valve. Lubricate the seal rings and the faces of the plates. You have to keep skin oil and acids away from these finely polished surfaces. Lubrication will do this. Be cautious as you install Teflon rings. Don't expand them too far to get them on. If you stretch them out too far, they won't return to their original shape. And be patient. You'll find installing rubber O-rings and Teflon backup rings to be a tedious, often difficult task, especially with the smaller rings like those on the poppet. Take your time, so you don't tear or cut any seals or seal grooves. The placement of the O-rings in relation to the backup rings is critical in several parts of the valve. First, at the seal rings, install the backup rings toward the sealing edge of the seal ring. Install the O-ring toward the spring side of the seal ring. In this way, the O-ring will be toward the inside, while the backup ring will be toward the outside. High-pressure fluid passes through the center of the seal rings and acts from the inside on the O-rings. The backup rings are on the outside to keep the O-rings from being pushed outward and pinched between the seal bore and the edge of the seal ring. Now the plunger seals. Put the O-ring on first and seat it toward the bottom of the plunger. Install the backup ring toward the top. This design keeps high pressure from forcing the O-ring out of its groove and into a position that could cause damage to the O-ring. The poppet is the last place you'll find backup rings. In this case, we have two backup rings on either side of a T-seal. This is the seal configuration on the 5,000 psi valves. In the 3,000 psi valve, you'll find an O-ring and a Teflon backup ring. When you replace these, put the O-ring on toward the head end of the poppet and the backup ring toward the Teflon tip end. When you've installed all the seals, it's time to put the whole thing back together. The reassembly procedure is basically a reverse of the disassembly procedure. Let's detail the critical points for you. At the seal rings and seal container, if you're using the old rings and plates, put the seal rings back into the bore in exactly the same positions they were before. It doesn't matter which side you place them in from, but place them in one piece at a time. Notice, too, the sealing edges and backup rings are toward the outside. After you replace the poppet and screw, give the poppet a tug, just to make sure the screw will hold it in. Make sure the screw is snug. You can even put a drop of Loctite on it to be sure. If you have to use a brass rod to seat the plunger guide, tap it gently. Then slide the seal container in from the bottom. In this view, you're looking through the inlet port. Notice the indentations can be seen here. This is critical, of course. These passages must face the inlet. In addition, the poppet screw should face the pipe plug here. The pilot valve housing and seat, an important point here. As you screw in the seat, stop when the bottom of the seat is flush with the bottom of the housing. When you reinstall the housing in the pilot valve body, double check to see the spring pin is out of the way and place the housing in from the top. You should be able to push it in by hand until it stops. If the pilot valve seat is flush on the other side, the top of the housing will rest just below the retainer ring slot. Now you can gently tap in the spring pin. Let's take a look at that old retainer ring. Compare it to the one we're about to replace it with. You can see the difference in the eyelet flanges. The one on the right, with the eyelets to the inside, is the correct one. Place the screen first, then the retainer ring. Use your retainer ring pliers. Now you can start replacing the flanges. As you prepare to do this, clean and inspect the cap screws. Use your wire brush or the wire brush wheel on a bench grinder to clean the threads. Replace any damaged cap screws. Refer to your valve drawing for the part numbers. As you're replacing a flange, coat only enough cap screws with anti-seize for one flange at a time. Don't do them all at once. They'll sit around and collect dust until you can get to them. The pilot valve body. If by any chance you forgot to mark this flange, it's no problem. This piece of metal is part of the vent passage, and it'll act as a guide pin when you put the flange on. So the flange can attach one way and one way only. The last assembly of the 1-inch MKR is the spring housing. The parts should come out easily. If the grease isn't gritty or dirty, you can go ahead and reassemble the housing and put it back on the valve body. If the grease is old and dirty, clean all the parts and re-grease them. Diesel is actually the best way to remove the old grease, but any solvent should do. Clean inside the spring housing too. In addition, there are 2 O-rings you should replace. One under the adjusting screw and one under the locking nut. Use a good, heavy, waterproof grease and thoroughly coat each part. Place the spring housing on, and your repair is complete. Your final step is to pressure test it at operating pressure. There you can make sure your repair was successful. One additional note if you're using this MKR subsea. The hydrostatic vent must be open. If you plug it, the housing may collapse, or the valve may work improperly or not at all. The 1-inch HKR. The repair procedures are identical to the ones you've just seen, with the few exceptions that we're about to show you. To show you those differences, all we need to do is pull the hydraulic head. Notice the pilot piping on top. This valve is even a fraction simpler than the MKR, since you don't have any springs to adjust. And so these are the only differences. The plunger and plunger guide are slightly different. As we separate them, you can see those differences. You can see the hydraulic port inside here where pilot pressure is applied. When you inspect them, make sure this passage is unclogged and clean. The rest of the differences amount to the position of a few O-rings and backup rings here on the plungers. In our next program, the 1/2-inch MKR and AKR. Like the valves in this program, the 1/2-inch MKR and AKR